We think we got our audio sorted out, folks. Scott has handed the presentation over to myself. It's Aaron Breimer here speaking. He was just giving everyone an introduction to the company. Deveron has two main focuses. One is around data collection, so that's soil sampling, imagery collection utilizing drones. And then the other half of our business is heavy on data insights. And that is the group that I manage and work with. So today's presentation is going to be around some of those data insights that we have created over the last couple of years. So Scott had posted the poll questions. We like to share some of the poll questions just for everyone to have an idea who's all involved. So at this point, it looks like the vast majority of you heard about this webinar through the email campaign. 5% of our folks on today are growers, farmers. 36% are independent agronomists. 26% are in the ag retail space, and 38% are from the ag tech world. And the question with regards to what is your current level of experience with variable rate nitrogen, 33% of you have indicated none, 28% have experimented with it somewhat, 18% are occasional users, and 21% have identified themselves as extensive users or that you have extensive experience with it. So this should be a fun group to share with. What interests you most about variable rate nitrogen? 26%, so just over a quarter, are indicating it's all about higher crop yields, or that's the most interesting. About 38%, 40% now is around reducing costs, and 33% is around improving the environmental footprint. See, question number 5. And for those of you waiting for my presentation to pop back up, just as soon as I get the polls done, we will present my screen. What is your limiting ability to utilize variable rate nitrogen? So multiple choice here. About a quarter is that you don't have the required equipment. About a third is confidence on the return on investment. That's going to be a lot of fun to share with you guys today, some of the data that we've been analyzing over the last 5 to 6 years. About 7%, it's a time piece. Tell me about it. We all get super busy, so maybe we can find ways to make your life a little bit easier. About a quarter is a knowledge piece, and another quarter is around just needing more customers to participate. And our final question, what is your preferred data layer for setting your nitrogen rate and zones? About 28% is experience, 30% is imagery, 37% is previous yield maps, 30% is pre-established management zones, and looks like we got a couple people that are wondering what we're talking about with data layers. So hopefully we get a chance to present that. And now I'm going to flip over to you guys being able to see my screen. All right, so everybody able to see my screen? It is the 5 pillars of success. So all good webinars have a little bit of a sales pitch, so we'll get this out of the way super fast and get into the meat and potatoes of the presentation. So the 5 pillars that we look at when we're talking about all things precision ag. The first, if my screen's going to work, is all around simplicity. If it's not easy, people are not going to use it. I grew up on a farm. My parents are still actively cash crop farming. And Dad is, Dad's 73 years old now. He does variable rate planting, variable rate nitrogen, auto steer, and collects yield data. If we didn't make it easy for him, he would not be doing it. So simplicity is very important. Those of you who indicated a time crunch, we all know that if things are not working the way they need to be when you start, you're going to turn it off. Next one, I truly, truly believe that every farm is unique. Not only is every farm unique, every field is unique. And for those of you who indicated it's all about management zones, I would agree. Even within the field, different things are going to be different. So understanding that the uniqueness is a critical piece. Deveron, we're all about innovating. We're constantly asking for feedback. We want to know what challenges you're facing. We want to understand what your objections are to what's being brought to the market, so that way we can find improvements and solutions for you. We are not interested in sitting still. One of the really cool things about our webinar series is that we like to share what we're working on so everybody else can have an idea of what it looks like and give us that feedback so we can keep moving. We don't have all of the solutions, but we have a strong desire to find the solutions. Here's a big piece. You guys were talking about the return on investment and feeling confident when it comes to variable rate nitrogen. We talk about validation. Did it actually do what it was supposed to do? And this can be a challenge, especially when every field is different. Every farm is different. Time is a challenge. What is a system to be able to validate and understand what is the return on investment? And then the final one is around this piece called inclusive. Some people call it a collaborative relationship. Farmers have a huge network of people that they can rely on. They have their ag retailers, they have their seed partners, they have their equipment dealers, there's extension folks. And for us, inclusive, that collaboration is how do we all truly work together? That is easier said than done. Everyone likes to talk about collaboration. It has been our experience that is a challenge. It requires a lot of trust, and it requires a confidence to be able to work together. We've got an offer at the end of the presentation around how we are going to give you guys a chance to test us out on that collaboration. So something to look forward to. All right, presentation overview. That's the sales stuff. Let's get into the good stuff. As I mentioned, I grew up on a farm. I've got my Bachelor of Science Agriculture degree, and let's see, 10 years in ag retail, followed by 9 years in the precision ag consulting space. And as I mentioned, I now am the general manager of our Data Insights Group. The Data Insights Group, we run under the brand called Veritas. So when you see that on the screen, that is it's the connection. So Deveron is the company, Veritas is the Data Insights Group within there. We're going to talk briefly around the nitrogen overview, some of the opportunities, some of the challenges. We're going to spend a nice bit of time around the promises and the technology. This presentation is around the facts and fables of variable rate nitrogen, and a lot of the facts and fables are going to live in the promises and technology that we see. Definitely going to go over a bunch of testing and results that we've had and how we execute that, so that way folks are able to get good input. And then finally, we're going to summarize the presentation. So into the good stuff. All right, nitrogen. I call it the sexy nutrient. And here's why. 57% of all fertilizer applied, this was the most recent numbers that I could get, indicated that 57% of all fertilizer applied in North America was nitrogen-based fertilizers. You can see 20% is phosphorus and 23% is potassium. For those of you who promote micronutrients, looks like those numbers didn't get lumped in. So it's these big three that are involved. Let's face it, nitrogen, for the most part, has an annual shelf life. And what we mean by the annual shelf life is that it's something that we have to address every year. It's not in most crops, in corn and wheat, cotton, in canola, a little bit different when we get into soybeans, but it does have that annual shelf life that we have to address it year in, year out. It's not that you can put extra fertilizer down and that's going to be around for a longer period of time. It is almost always one of the top three costs that a farmer has to deal with. The deficiency is visible. This is a nitrogen response trial. You don't have to be a very good agronomist to be able to pick out where the nitrogen deficiency is. And in fact, in my experience, I have yet to meet a farmer who was honest with me that has never done an accidental nitrogen trial at some point. Whether they skipped one pass, whether they ran out a little soon, whether it was that weird corner that they couldn't get into, whatever the reason was, at some point a farmer has done an accidental nitrogen trial, and we all know that nitrogen pays. So there is a pile of research. Every land-grant university that I'm aware of has done extensive research on nitrogen, because it's one of those questions that keeps coming up. Because let's face it, as I said, nitrogen is sexy. Another piece, there is huge field variability, whether it's soil type, whether it's management, and we'll get into some of this further into the presentation. Field variability has a huge impact around nitrogen. When we talk about the validation, I'll get into a little bit more on this. And then the other one, and this showed up in the poll, this was a significant concern, is around the environmental impact of nitrogen fertilizer. A university professor of mine describes nitrogen as a leaky system. So all good certified crop advisors and agronomists are very familiar with the nitrogen cycle. So I'm not going to go over the nitrogen cycle. What I am going to talk about are two sets of variables. And the first set is what we call these controllable variables. So this can be your crop type. If you are growing soybeans, you do not need to worry about nitrogen, or not very much. If you're growing corn or wheat or canola or cotton, then you do have to worry about it. And you do have to be able to manage it. Corn requires a lot more nitrogen than wheat, for example. The other piece in our control is the fertilizer application. So this is comes back to the 4 R's: the right time, the right place, the right rate, and the right source. So that is something that we are able to control as agronomy or as agriculture professionals. And then the final one that I mentioned here as a controllable variable, as a little bit of a segue to the uncontrollable, is irrigation. If you have the ability to irrigate, you can control that to a certain extent. Most irrigation schemes that I have seen, there is often some restrictions as to how much can be irrigated, when it can be irrigated, and pieces like that. So it's not completely controllable. And let's face it, there's a lot of corn production, a lot of wheat production that does not have irrigation. So hence the asterisk on that one. And the uncontrollable variables, like I said, that irrigation is a segue, because weather. Weather is a huge part of nitrogen and making it a leaky system. The rainfall, the patterns of rainfall, when it's coming down, the temperatures involved, a pile of different pieces in there. And then the other part is soil properties. Some people could argue that you might be able to modify the chemical properties slightly, but that is going to be pretty expensive in my experience. But then the physical and biological, once again, maybe you can modify it or influence it, but you cannot completely control it, in my experience. So if you're into the whole leaky pipe, if you're not a big fan of the nitrogen cycle, there it is exactly. So you got your nitrogen disappearing from different sources. If it was a straight full pipe, this variable rate nitrogen would be easy. Unfortunately, that is not the case. Technology overview. All right, here's the good stuff. Everybody seems to love to talk about imagery indexes. This can be NDVI, something called GNDVI. You might hear about red edge. Not going to get into the big sciences behind it. Here's what it is. It's using wavelengths, reflectance from the plant, and it's creating these different indexes, these different ratios, if you will. So the NDVI, which is probably the standard for most of agriculture, is taking the near infrared, subtracting the red band, and then dividing the whole thing by the near infrared band plus the red band. And here's why. The majority of plants, not all, but the majority of plants, this is what the photosynthesis absorption is. So this is how the plant gets its energy. It's either blue light or red light. And so when you get into a lot of these indexes, they're looking at either that red light or they're looking to a lesser extent that green light. And what's going on here is, so near infrared is to the right of that red curve where it's disappearing. So what we're trying to analyze is what is the ratio that the plant is absorbing of that red light. So that is what a lot of these indexes are doing. And a lot of it's done by what we call multispectral sensors. For some reason in the industry, we like to use fancy words. This is basically a specialized camera that can capture different wavelengths of light. That's literally what we're talking about when we're talking sensors. It is a camera. Here is the major part that makes NDVI work or not work. And that is the assumption that nitrogen is your limiting factor. It is not always your limiting factor, and that is the challenge behind this. There's a concept called hyperspectral imaging, and basically, so multispectral camera, you might have 3, 4, maybe 5 different bands of light, and then you can look at different combinations. Hyperspectral is this massive data set. I've seen sensors, cameras that can capture up to 256 different segments, and then you're getting into all kinds of combinations. You're talking massive statistical analysis on this. Not saying that it won't ever have a fit for us, but at this point, hyperspectral is the realm of the researchers. Like I said, sensors, this is your cameras. So this can be the handheld. I've seen different handheld ones that you can take a NDVI reading. You can definitely set up sensors on the drones. And a lot of people are starting to have crop health maps or NDVI maps from satellite imagery. Just like sensors is cameras, everyone likes to talk about algorithms. Algorithms, all it is a simple equation. Well, maybe not simple, but it's an equation. It would be so much easier if we just told end users that's what it is. It's that your NDVI is this score, the equation says you need to put this much nitrogen down. The challenge with algorithms is they require constant ground truthing, testing, or a pre-side dress nitrate test, or a pre-plant nitrate test, or a post-harvest stock nitrate test. So you need to be taking all of those different testing to make sure that your algorithm is accurate. Unless you are going to go to the assumption that one algorithm is going to work for every farm, for every field, for every management zone. I believe that every farm, field, management zone is unique. So having one algorithm that's going to work for everything is a little bit of a challenge from my way of thinking, and some of the examples that I will show. In my opinion, if you are going to do variable rate nitrogen, you absolutely must be testing. If you're not testing, you're setting yourself up to not be able to take full advantage of it. Next piece that I want to talk about is this concept of buffering of the soil of nitrogen. So it's literally the ability of the soil to provide a stable source of nitrogen available for root uptake. So it could be soil types. So here we have 2 different soil types, and you can see depending on the year where the optimum nitrogen rate is. 2 very different soil types, and you can see that the curves are different. So you, once again, taking into consideration what's going on with that soil. In my opinion, it's influenced by organic matter, soil type, and a big piece is management practices. Talk about soil water supply as well. But if you look at management, so if buffering capacity is nutrients into the roots, so the nutrients can be available, but if you mud your corn in, and you know what I mean by mudding your corn in, you got on there just a little bit early or on the heavier part of your farm or the headlands, and you cause some compaction, the roots can't get out, you're going to have a challenge. I've got another data set. This is from a long-term study. This is actually 10 years of different optimum nitrogen rates, exact same site. So your soil types have all stayed the same, but weather is influencing it. So this becomes the challenge, is trying to figure this part out. From that study, there is a strong belief that soil water has started to play a big part. So if you go back to Liebig's law of the minimum, we were talking about soil conditions and other growth factors like the management, but then you've got this water and nitrogen and how they're influencing each other. So from that 10-year study, rainfall from V5 to V12 is showing a very strong correlation to what's called the maximum economic return of nitrogen. So depending on which paper, you might want to use optimum nitrogen response rate. There's different terminology. Basically, it's what is the ideal. And you can see there's fairly strong correlation to that based on the rainfall. Each one of those data points is a different MERN based on the different year. So in every case, this was the same variety. You can see the MERN, which is the maximum economic return of nitrogen, has very little correlation. So the closer to 1, the higher your correlation is. So from planting to the V4, very little to no correlation. You can see in that V5 to V12, and if you're wondering what MEY is, that is the yield that is achieved when you hit the MERN, that maximum economic return. But very little before that V5 to V12, and then very little after that V12. So when you're into that VT and R1, or even later. So this is assuming that 1 or 2 passes of nitrogen. Here's the thinking behind why this is actually something from Ross Bender, who works for Mosaic, and he is segmenting where the nitrogen is heading in the plant. And you can see right around the V10 stage, the corn plant just goes absolutely wild for nitrogen. It sucks up as much as it can. And so up to that stage, we're trying to get, guess is not the right word. We're trying to accurately predict, and accurately is in air quotes in this case, around what is your ideal nitrogen. So I've indicated that anything past V10, nitrogen becomes critical. We are attempting to match the side dressing with the potential yield. Now, nitrogen moves through mass flow, so it requires water. So if you don't have water, trying to get it into the roots is a challenge. So waiting until V10 is great because you're going to have a better idea. Am I dealing with a 250 bushel corn crop, or am I dealing with a 150 bushel corn crop? The challenge is if you wait to V10 and you don't get any rain and you've got that nitrogen sitting on the surface, trying to get it into the roots is next to impossible. If you go and you put your nitrogen on at V5, you have a better chance of getting that rain to get the moisture, get the nitrogen down into the roots. However, you don't have as much of a window as to the optimum time to get nitrogen down. One of the things that we see in the industry is this concept of Y-drop. I'm mentioning Y-drop. There's a bunch of different systems on the market. Basically, it's drop piping on nitrogen down into the canopy, and the idea being that the limited rainfall from the corn plant acts as a funnel and gets the nitrogen down right around the base of the plant. The challenge with this is most application systems are putting this on at the 6-7 miles per hour. I challenge out any of you to put a GoPro camera on one of these machines at 6-7 miles an hour and watch how those hoses are whipping around. They are not able to place that nitrogen right by the row consistently. It is going back and forth all over. So you need that consistent rain. This is a study coming out of Aaron Stefanos, who was with an ag-reliant seed brand. He is now with Mosaic as well. And what he did was he planted 3 different varieties, and he did 4 different nitrogen programs. He did no late season nitrogen. He put nitrogen down just at the V8 stage. He put nitrogen down just at the V12 stage, and then he did a combination. So that is your fixed years or your fixed varieties. You can see the really no response difference between V8 and the combination. Waiting too late definitely had an impact. This is what we call the fixed around, so or flex around. So this is the corn varieties that can alter the number of kernel rows. And then the final one is the fixed long, and these are varieties that adjust the length of ear based on moisture, rainfall, nutrients, pieces like that. It's a great study to be able to understand how different hybrids are interacting with it. Once again, showing that you have to take all these variables into consideration. All right. Now we're going to get into how we validate a script. This is something that I find very interesting, but I'm a little bit of a math nerd, so I'll do my best to explain how this works. What we do is we create a management zone, and then we insert randomized check blocks all over it. So it can have all kinds of different rates. So literally every one of our scripts that we send out the door, we turn into a complete randomized block design. So those of you who are statisticians will understand where I'm coming from with that. We set it up so it's super simple, that nothing extra has to be done. You don't have to be leaving check strips. The check blocks are doing all the work for you. You run the script, automatically it's taken care of. Now, when we do the analysis, we are not using the target rates, which is what these what the script is running. What we actually take is we take the actual as applied data. So that allows us to have a continuous flow of different data points. And we split those blocks up, so we're getting a lot of data. And we use a regression system, and we split it out, as you can see, into different management zones. So this was one of, I thought I had nitrogen figured out about 5-6 years ago. I wanted to put more nitrogen down where the corn was going to yield 300 bushels per acre. So that's what I thought I needed to do, and that's what I attempted to do. And boy, was I wrong. What we found was that the best response to additional nitrogen was the medium productivity and the low productivity zone. The high productivity zone actually did not need excess nitrogen. And one of the thinkings behind why that is the case is because if you think about it, in a lot of cases, that high productivity zone has a lot of extra nitrogen around because of organic matter. I'll show you what I mean. So nitrogen from organic matter. If you take a furrow slice, which is the top 6 inches of soil, works out to, on average, 2 million pounds. Yes, I realize different fields are going to be different, but on average, bear with me, 2 million pounds in the top 6 inches of an acre. So if you took it all off and you weighted, that's how you come up with that number. For every 1% that is organic matter from your soil test, that means 20,000 pounds in that 6 inches is as organic matter. Now, if you assume 15% of organic matter is nitrogen, and I have seen numbers from 12.5 to 17.5 from the research, so I used 15%. If you want to argue one way or the other, by all means, the concept stays the same. At 15% of organic matter, so for every 1% of organic matter, you have 3,000 pounds of nitrogen. So if, for example, if you had 3,000 or 3% organic matter, you actually have 9,000 pounds of nitrogen locked up as organic matter. Going back to the research papers, once again, between 2 and 2.5% of all organic matter is mineralized on any given year. Yes, I recognize that some papers are going to say it's 1%, and I also have papers that will tell me 4%. I will tell you it changes depending on the year. It depends on the soil type. Once again, this is why we're doing PSNT tests, pre-sidedress nitrate tests, pre-plant nitrate tests, because we're constantly evolving it. But if you were to take that to 2.5%, and if you had a soil test that had only 1.5% organic matter, I recognize for some of you that are on sharp sands, that might be a dream to be at that point. But at that point, you would be looking at between 90 and 110 pounds per acre of nitrogen is mineralized. Now that's assuming that the roots can get to it. Management zones, stuff like that, management practices all come into consideration. If you had doubled it, so 3% organic matter, some of you clay guys will be able to relate to this, it can be up to 220 pounds per acre that is mineralized on any given year. Doesn't mean it's going to happen every year. And the other piece that I want to stress is nitrogen mineralization is a very, very dynamic process. Please do not go away from this webinar thinking that if you have 3% organic matter, that you don't have to put any nitrogen down. That is not what we're saying at all. What we're saying is that there's a lot of nitrogen available there. It all depends if it's actually getting into the roots. I'm going to use an example. This is actually from my father's farm a couple years ago. And based on the experience that I had before, the lower productivity zones, so the red line, I put more nitrogen down. And you can see there was a little bit of a response, but it dropped off pretty quick. The second lowest productivity zone, that yellow line, shows a continuing declining curve. Not exactly what I was expecting. It's actually, and if you look at the green and definitely the blue, in the case of the blue curve, that's the best ground. And I wasn't getting enough nitrogen on there. So my father was not super thrilled to see these results. And this is why it comes back being important to be constantly testing to understand if it makes sense with what your rates are going to be. Now, one of the things with my father that he absolutely loves to do, and those of you who are paying attention, my dad loves to work with cover crops. And I'm not going to get into cover crops a whole lot. We're going to have another webinar around cover crops in the near future. But is to understand the carbon to nitrogen ratio. What we have found is that if you are doing corn on corn or oats and cereal rye as cover crops, what you actually end up having to do is you have to invert the thinking that we had originally. And that is, the corn on corn, you're going to have a lot of residue on the best part of your ground, and that extra carbon is going to soak up that extra nitrogen that is being mineralized. Like I said, it's a very complicated situation. Same with oats and cereal rye. You've got to be able to manage that. Same with manure application. It's basically an uncontrolled, slow release, fast release, depending on the year release, and understanding are you incorporating it, are you experiencing compaction, how are the roots interacting with that nitrogen. Tissue testing, soil testing to understand what's available in order to be able to make the best recommendations. I'm sorry, but I really disagree with the idea that one algorithm is going to solve all of this. It can make significant money, but you have to be thinking about, okay, what actually makes sense. Management zones, great idea, but think about what you actually want to do going on with that management zone. Another part in cover crops is legumes. This is a winter wheat field, very common in some parts of the world to spread red clover seed in the spring. And then after the wheat, the clover grows up. And in the fall, they terminate it and thinking that there's a nitrogen credit. You don't have to be a rocket scientist to figure out that there's huge variability there. We're actually doing a fairly significant study. We have 21 sites this year where we are actually counting clover plants, find the fields for NDVI to try to measure the clover, and then taking it to the following year and doing variable rate nitrogen on there to see what the nitrogen response is. Once we have that data, we'll be happy to publish it and share with all of you. Now, interesting thing that we have already found on that, because this was actually started last year, so this is our first year we're doing the actual nitrogen, is the number of plants that tends to correlate very nicely to the clover, the coverage that we see in the field. However, the clover coverage tends to correlate very nice to the NDVI. The conclusion you'd like to draw is that plant counts should correlate to NDVI, and it does not. So a big part of this study for us is going to be, is it plant counts that's important? Is it clover stand, like clover coverage, or is it the health of the clover, that NDVI, that is correlating with nitrate levels, and then also into the yield results? So variability, huge piece. Almost done. Something else that we've been working with is this concept of green snap. So we're able to use drone imagery to be able to identify and quantify how much green snap is happening in a field. So this is, you can see the bare ground image on my left, as well as a imagery index. All of those tiny little black specks, that's where green snap is happening. Now, if you start looking back and forth between those two pictures, you'll see a lot of that green snap tends to be coming from that darker soil type, especially down here in the bottom left corner. There was a lot of green snap there in a lot of cases because of that extra nitrogen. And here's what's going on. Some of you might be familiar with Mulder's chart. Nitrogen has an antagonistic approach or impact on both boron and potassium. And both boron and potassium are important in cell wall strength. So having extra nitrogen around, so pumping extra nitrogen down either pre-plant or side dress, and then also having all that extra nitrogen coming, being released from that organic matter is leading to both boron and potassium being antagonized, and end result is we are seeing more cases of green snap from excess nitrogen. So it's another part of that puzzle that we're looking at. Crop health maps, this is actually a wheat image. So this is what we call red, green, blue. This is what you see with your naked eye. This was taken last fall. This was a crop health map coming out of a satellite this spring. And as you can see, there's an area towards the left that the crop health is not very good, and it doesn't seem to correlate very well with that first image. So the question is what's going on there? Well, based on our experience, where the crop is not as healthy, we need to be putting more nitrogen on. That has been our experience. So that's what I would normally recommend. However, talking to the grower, that area that does not have good crop health, it's not that it doesn't have good crop health. The crop is dead. What happened is it's winter kill. There was snow that melted and then ice, and it just killed the wheat. So putting extra nitrogen on there, extra nitrogen is not going to bring back a dead crop. So what we actually did was we created a more or less an on-off script that would turn his sprayer off as he was going across those dead areas. So once again, just assuming crop health and that's how you're going to do it, probably not ideal. All right, summary. Variable nitrogen has a lot of moving parts. I think everybody has heard that. There is definitely no magic solution. There's huge parts around the economics and weather. The longer that we can hold off on applying nitrogen and still ensure that the nitrogen is going to get down into the roots, the better the economic certainty of our recommendations. Definitely can use the imagery. I love using management zones, whether they're based off historical yield data, or whether they're based off of imagery. Absolutely love it. But you need to be looking back at what's going on with the productivity zones. Here's an example. I think this was actually included in the invitation to this webinar, a field that I've been working with. This is actually management zones based off of 3 or 4 years historical yield data. Now, it's 3 or 4 years of historical yield data, but these management zones have been pretty static. And on any 1 year of yield data, I can probably come up with something very close to this. So it's not a case that you need to wait 3 or 4 years. Just like with that wheat example, you can go in there with variable rate nitrogen in your with just 1 year of imagery. Test, and more testing. Yes, you can put in check strips. Yes, you can put in check blocks, but you need to be able to analyze that data afterwards. We are all busy. If you're not comfortable analyzing the data, or if you want some help, we would be happy to talk to you. We do not have to write the scripts. If you want to write your own scripts and ship them over to us, we will be happy to put our validation system on there and work with you to be able to validate it. We don't have to put our name on any of your material. We're here to support you. So, call to action on that. huge economic opportunities for both the farmers and the industry on this piece. Let's face it, farmers love to spend money. If you add a little extra money to a farmer's bottom line, they will spend it. Environmental sustainability, hey, that's for all of us. We need to be doing a better job around nitrogen. And here's the thank you for everyone. Reach out to Deveron. I think everybody would have gotten an email from either Scott or Carla or Josh, my colleagues, and they would be happy to have a chat with you around getting you that validated script. After this presentation, you're going to get another email from them. Feel free to shoot them back a direct email. Reach out to us through our website. We would be happy to make sure you guys were able to take advantage of that. Also, if you just want to have a chat with me, there's my contact information. I do exist on Twitter. I have been known to get myself in trouble once in a while on Twitter, so I try to behave myself, but if you do want some entertainment once in a while, I do get into trouble there as well, and my email and phone number as well. Would love to talk to any of you, and yeah, I am going to end my presentation now, and we're going to try to get Scott back online and see if his audio is a little bit better. All right, Scott, can you hear us? You there, Scott? All right, looks like Scott's still having some technical difficulties. Let's take a look at what questions we've got. First question is CCA CEUs. Yes, we have registered for them. We expect confirmation any day now. We will send out an email on how you can get those CEUs. So perfect for that. Next question is around the data layers. What data layers do you use to create management zones for nitrogen? Like I said, my favorite management zone tends to be yield data. Now, when I talk about yield data, is I don't take just any yield data. I work in an area that does have some winter wheat. Winter wheat loves to find unique ways every year to try to kill itself. And so because of that, taking wheat yield data and adding that into any algorithm can be a little bit of a challenge if you want to use that as a historical data layer. So I'm always a little hesitant to be using wheat data. Same with on soybeans. Soybeans are great yield data until you get a year when you get a lot of white mold. For those of you who grow soybeans on 30 inches or on heavy ground or sharp sands, it might be very uncommon for you guys to see white mold. There are areas that grow soybeans on 15 inches or even 7.5 inches. And in those cases, especially where it's a little growthy, or if we start getting on a nice bit of rain, you can see white mold start to build up. And in those cases, you can have significant yield loss. So now, all of a sudden, your soybean yield data is suggesting that your best or highest yield potential area is actually one of your worst. So once again, when it comes to data layer, when I'm talking to individuals around the data layer, the absolute most important data layer is the data layer between your ears. It's the experience you have on that farm. Including the farmer into the conversation is absolutely critical to make sure that you're taking full advantage of that. Next question is, how are recommendations made? So the recommendations that I use, I will start off with a fairly limited range of nitrogen rates. One of the things that I have learned with variable rate nitrogen is if a farmer comes to me and says, listen, I want to spend, let's say $75 per acre on nitrogen. I want to put down 175 pounds of nitrogen as an average. Can you help me put that nitrogen in the best possible spot? Yeah, I can probably do a fairly decent job of that. I need to take into consideration what is the crop, what is the soil type, what is his management, what was last year's crop, but I can get a pretty good handle if I've got some good management zones to move that nitrogen around. Now, that same farmer comes to me and says, hey, I want to maximize my yield. What amount of nitrogen should I be putting down? That is a very tough question to be able to answer because it's moving year to year. The longer that I can hold off to be able to make that nitrogen recommendation, the better, the more confident I'm going to be. But like I said, now you got this issue as, am I going to get rainfall to get it in? So for those of you who have the ability to turn on the rain, i.e. irrigation, that is going to be a huge asset. But if you're looking for a general idea, what I will do is I will split a field into either 2 or 3 zones, and the lower productivity zones, unless they're drowned out, so always an exception, unless they're drowned out, those lower productivity zones, I usually go about 20 to 25 pounds above whatever the average is. And in the lower or in the higher productivity zones, where that higher organic matter is, where it's going to mineralize a little bit more nitrogen, I'm backing down 20 to 25 pounds. That's where I'm going to start, and then I'm going to be testing every year to be able to fine tune that a little bit further. All right, next question. Do you have a protocol for taking PSNT soil sample cores in regards to corn crop, row spacing, and where the cores are taken? Great question. So our approach on this is that we want to take a 12-inch. This is the soils that I'm familiar with. I'm definitely open to seeing different approaches, but I'm taking a 12-inch core. I'm segmenting it into both 6 inches and then 7 to or 6 to 12 inches. So I've got a shallow and a deep nitrate test, and I am doing that ideally 1 sample in every management zone that I've got in that field. That's as a bare minimum. If I have my choice, I want to be able to be taking 2 in each zone. It takes a little bit more time, but that is the approach that we use for PSNT. Timing-wise on that, I try to do it about 7 days prior to when the farmer is wanting to side dress. My experience with PSNT tests, one of the challenges is you do have to keep those samples cold. So I'll make sure that I've got a cooler. So next question. Are you also doing variable rate seed prescriptions as well? So putting more seeds per acre in better management zones, does that change the nitrogen rate? And that's actually coming from Lee. Lee, I love that question. That's actually where I first cut my teeth on variable rate, and that's actually where the whole validation curves come from, is from doing the work with variable rate planting. Or variable rate seeding. It really started off with variable rate corn, and then have moved into variable rate soybeans, variable rate edible beans. So yes, a lot of experience on that. That actually goes back to the last 10 years. As a general rule of thumb, because you're asking, does that change the nitrogen rate? I'm assuming you're talking with corn. It does somewhat, not as much as you would think. Actually, the bigger piece that comes into play is understanding how your seeding rate is being influenced by your phosphorus and potassium levels, because those phosphorus and potassium levels are going to drive stalk strength. One of the cool parts about how we do variable rate validation is those check blocks. You can put some pretty cool outlier rates. So with the example I always like to use is my father. My dad likes to push the envelope, so I was able to put in those check blocks, and those check blocks are about 120 feet by 120 feet, so about 1/3 of an acre. And those check blocks came the next year. We went at 40,000 in a couple of them. They were completely flat. Now, most farmers don't appreciate when you cause the corn or the crop to go completely flat. However, in that case, my dad was really glad that he was just dealing with about 6 or 7 check blocks of flat corn instead of having a third of his field flat. So that is something that I see a lot of value in. Is being able to push the envelopes and see how things interact. And like Aaron Stefanos, who's with Mosaic that I mentioned, he's is showing that even variety sensitivity is a big part of that. All right, so that's all the questions there. Let's see if we've got some more questions in this other spot. Would like to see an example of one of your prescription algorithms. If that is private, then I understand. I don't like any of the ones that I have used in past years. Roger, I agree with you. The best algorithm is the one that you buy into and that you can validate. Like I said, if you reach out to us, I would love to have a chat with you, and let's see if we can build an algorithm that works for your farmers, or if you're a farmer, for your ground, and one that you can feel confident in. So yeah, we will definitely make sure to work with everyone and anyone who wants to add value to the farm operations that they're involved with. And with that, we are out of questions, and I've got 2 minutes to spare before the end of the presentation. I want to take the time now to thank everyone for participating. Those were some great questions, and I had a lot of fun sharing what we're working on with nitrogen. Keep an eye on your email. I know Scott has a bunch more webinars planned, and we've got some pretty cool topics and more data we want to share, especially with the cover crops. We've got some really cool stuff on cover crops coming. So that's the teaser, and looking forward to talking to you guys again soon. Thanks.